Today we're going to focus on 3 types of plate boundaries. And if you look at the bottom of the screen, we have divergent plate boundaries where plates are moving away from each other. There's convergent plate boundary where plates are colliding. And there are transform plate boundaries where plates are sliding past each other. So today we're going to relate plate tectonics to the formation of crustal features. And this is a nice picture because it's showing you the different plates on Earth. There's about 15 different plates. And you'll see the common big plate names in some of our studies. Transform boundary is the first type of boundary. This is a boundary between 2 tectonic plates that are sliding past each other. The result are faults. Earthquakes are going to occur at all plate boundaries. So let's look at the direction of the motion of a transform boundary. So again, transform boundary, you have the plates sliding past each other. The type of crustal features formed would be a fault. An example would be the San Andreas Fault in California. And this is an aerial view taken from the sky looking down at the San Andreas Fault. Again, on earthquakes are going to occur at all boundaries because these plates are going to move. When enough force is built up, an unbalanced force occurs, and then we have motion, which are earthquakes. Divergent boundary. This is the boundary between 2 tectonic plates that are dividing away from each other. The crustal formation depends on the type of plates that are diverging. So let's look at the direction of plate movement for diverging. So here your plates are dividing. They're moving away from each other. So let's focus on the type of plates that are diverging. If we have a continental plate diverging, we get a Rift Valley. This would be, an example would be the Great Rift Valley in Africa. So you have part of Africa diverging from the other part of Africa. If we look at an oceanic plate and an oceanic plate diverging, a mid-ocean ridge forms, and this is a mid-ocean ridge here. So what you would have is an example would be the North American plate where we are diverging with the Eurasian plate to the right, and what would form would be the mid-Atlantic ridge. So here's the North American plate, and here's your European plate, and all the way down here in the middle of the Atlantic Ocean, you have the mid-Atlantic ridge. So this is happening at the bottom of the ocean floor where the plates are diverging. The third type of plate boundary is convergent boundary. This is the boundary between 2 colliding tectonic plates. The crustal formation depends on the type of plates that are converging. So let's look at the direction of the movement. So here at a converging boundary, you have plates coming together or colliding. And what we want to know is what type of plates are colliding. So if we have a continental plate colliding like India and China, you're going to get mountains like the Himalaya Mountains, the tallest mountain range in the world. And they keep growing taller and taller because of the convergent boundary that they're on. Mount Everest is also found here. If we look at a continental oceanic plate converging, like the Andes Mountains in South America, we have that Pacific plate converging with the continental plate. And so the oceanic plate is going to subduct, okay, melt inside your mantle, and it's going to push magma up and make volcanic mountains or volcanoes here. And if we have an oceanic plate converging, coming together or colliding, what you get are island arcs, and we can look at the Aleutian Islands up in Alaska. Okay, trenches are also formed in the ocean, those deep depressions.